Okay, so today we're going to be doing 9.4, which is properties of logarithms. So we have the product property, quotient property, and the power property of logarithms. And these properties go two ways. You can either condense or expand. So the product property states that if you have the log of something that's a product, you can separate those two products and turn it into addition of the two separate logs. Okay? So say you have like log of xy. That's the same thing as log of x plus log of y. And the reason these operations work this way is because we know that logs are inverses of exponents. So we know that with exponents, if we have like x to the fourth times x to the fifth, it's x to the ninth. We add the power. So it's the same idea with logs as well. Quotient rule states that if you have log of something, like m divided by n, you can switch it to subtraction. And keep in mind, just like with division, subtraction is not commutative, so the order does matter in which you subtract them. The power property states that if you have a power on whatever's inside the log, you can bring the power out front, okay? And then these rules apply also for natural logs as well, okay? The main thing is, if you do these rules, you have to make sure you maintain the base throughout the whole problem. So we're just going to prove the properties and just talk about why they work. We'll fill in some of these. It's going to get a little redundant, but you'll get the idea. With addition, we know that we can rewrite it as log of 3 times log of 2, right? That's part of the rules, which would equal what? Log of 6. So log of 6 is the same thing as log of 3 plus log of 2. So it's just going to be like very redundant. That's what just showing how these rules work, okay? Same thing for natural log, all right? I'll zoom out so you guys can see everything. So with the natural log, it's the same idea. It's going to be ln of 4 times 5, which is what? ln of 20. So it's the same thing as above. So these are just multiple representations of the same thing, okay? This one here is subtraction, so it's the same as division, right? Which is equal to what? Log of 4. You guys see how those are one and the same? You don't have to fill this out, it's just this, okay? When it's subtraction, like I said, it turns into division, okay? And that's going to be the same thing as this one. Now for the power property, the power can go back onto the log, okay, which would become log of 125, which is 5 to the third power. And then once again, you can put the power back onto the number on the inside of the log, which would become log 16, or ln of 16. Oh, this is ln, my bad, sorry. So that's just like an overview of how these rules work. We're going to practice expanding and condensing together. All right, so you're just going to apply a bunch of these rules. That's really what it is. Okay, so we're going to expand the following logarithms. So with expansion, your thing's going to get bigger. Okay, so it's going to get bigger. So let's talk about it. First thing you want to do is you want to look at what we're looking at log of. In this case, it's log of x cubed, 7 times x cubed. So first thing we're going to do is, do you notice the operation between the 7 and the x cubed? What kind of operation is that? Multiplication, right. So since it's multiplication, we can rewrite it as addition, right? That's the log property. Only if you put logs around them will this work. So any questions about that first step in expanding? So multiplication converts into addition with logs because logs are inverses of exponents, which have these rules as well. Next rule. This one is going to stay as is, but for the next one, what do you notice about the exponent? What can we do with this exponent? Bring it out front. So exponents gets to go out front, okay? And keep in mind, whatever base your log started with, your base shouldn't change throughout the problem, so it should stay the same. So it's a common mistake to kind of forget to write the base in there, so just don't forget on the quiz or test to write in your base. So that is the full expansion. I can't expand this any further. So does anybody have any questions? Now, technically speaking, you could write this as like log base 2 of 4 plus log base 2. You know what I mean? Like you can rewrite it in a way, but you don't have to do that. All right. Next one. So what operation is between all of these here? Multiplication. So we can expand each one of those into a separate log, or ln in this case, with addition between them. And then what do we do with the exponents? Bring them out front. If you have an exponent, bring it out front. So that's what we call expansion. Logarithmic expansion. Gets bigger. And that's fully expanded at this point. So any questions about logarithmic expansion? And if you want to understand why this works, you can also in your calculator put in you can see ln of 6 is the same thing as ln of 3 plus ln of 2. You can always verify that too. All right. Letter C. First thing I have is division. So how can I separate that? Subtraction. Okay. Next is we have multiplication. So I separate that by addition. Next, we have exponents. So what happens with the exponent? Out front. All right, that's everything? Yes.
Do you need parentheses, everything before the subtraction? Because you're subtracting that whole thing. Because you have to do all that.
You mean like this part right here?
Yeah, but on the last one, from log 5, from first, you know what I'm saying?
So this became this. And then that.
So do you have to put parentheses around the whole?
Oh, no, you don't have to because this is subtraction from this whole thing, right? It's addition and then subtraction. So with order of operations, we already know we do addition. Do you see what I'm saying?
Yeah.
Okay. It's hard to explain, but hopefully sometimes it's second nature to me that I don't even think about it. So yeah, you don't need to. All right, letter D. So there's a few different ways to do letter D. You can either deal with the exponent on the outside first, or you can put each one of these to that power. So I'm going to do it putting it out front first. So I can start by just bringing this 4 out front. Because remember, exponents can go out front. And then from here, we're going to work with simplifying the inside, right? So the inside, it's division, so it's going to become subtraction. Good. And then here we have multiplication, which is going to become addition. And then lastly, exponent can come out front. Now, this is almost fully expanded, but the last thing we have to do to fully expand it is to distribute this 4 onto each of those separate terms. Okay? So that's going to become 4 times ln of 2 plus 4 times ln of x minus 12 times ln of y. So does anyone have any questions about that? Yes.
Why did you put brackets?
Because when I took the 4 out front, it's still part of it's on the outside of each one of these that gets expanded from this point on. If you didn't want to have to worry about that, another option would be to rewrite this initially as 16x to the 4th
Oh.
over y to the 12th. And then if you had done this, you would have gotten the same result in the end as I got.
So it doesn't matter if it's brackets or parentheses?
No, I just, when there's already parentheses, sometimes you'll see like me use brackets just to show you that they're like, which ones,
Different.
yeah. But you don't have to. It's not wrong to do parentheses, no. Alright. So now we're going to go backwards. You see how this one is already expanded? Now we're going to reverse it back to condensed form, okay? So step 1 is to make sure they all have the same base, and then I like to work from left to right. So I'm going to try to see if I can do anything with these two first before I deal with this one. We're going to work with that one in a minute. So between these two, what operation is occurring right now? Good, and they're both in their own individual log. So if I want to bring them into one log, I can change it to multiplication. So it's going to be log base 7 of 8x squared, and then I just bring down the next one. Because one step at a time, we're just going to do it step by step. So now I have the addition of two logs with the same base. So if I want to bring them together, once again, I have to do multiplication. So I'm multiplying 8x squared times 3y, which is 24x squared y. So that would be how you condense. Okay, condensation versus expansion. All right, B. So between the first two, I have what operation? So I want to convert them into one log. I have to change it to. Good, but which one's going to go on top here? The y. Does the order matter here? Yes. Because with division and subtraction, we know that order matters, right? So we get here. Now, can we condense this even further? Yes. This is going to become what between them? Multiplication. And when you multiply a number times a fraction, you can put that single monomial over 1. And then what can I do to simplify this? Multiply across, right? But we can actually simplify that one further, right? What's it going to become? 2xy over 5. So I just ultimately reduced that fraction there. So does anyone have any questions about that so far? Okay. And then if you like to, instead, like what I usually, you can also cross cancel here if you want. That would also have worked, whatever method you like to use to simplify fractions. All right. Letter C. So before I start combining any of these, I notice that I have some numbers out front that I have to deal with first. So how can I move those numbers out front? They're going to become exponents again, right? So these are ln of 5 minus ln of x to the 7th plus ln of y to the 2nd. Now I'm going to work this direction. This is subtraction, so it's going to become division. And then between these, it's addition, so it's going to become multiplication. Which ultimately becomes ln of 5y squared over x to the 7th. So any questions about that one?
How did you know where to put the y?
How did I know where to put it?
Like, why did you only do it up top?
Like here?
Mm-hmm.
Oh, it's because when I'm like multiplying, I'm multiplying this times this, but in reality, it's really me multiplying a fraction by a regular like monomial.
Oh.
So I have to put it over 1. All right, this one. Can I start with the changing the subtraction yet? No. What do I gotta do first? Put the exponents back. So it's ln of a cubed minus ln of b to the 6th power, which becomes ln of a cubed over b to the 6th. So unfortunately, not much I can do with that, 2 different variables, so that's as far as we can simplify it. So does anyone have any questions about those so far? All right, and then the last thing we're going to do is we're going to learn how expansion and condensing can help us actually solve problems similar to what we have already learned about. So you'll notice that this one is expanded, right? So what we're going to do is we're going to see if we can condense it to be able to solve for x. So if we condense it, what's this going to become? Log of 8x is equal to 2. Now, we're missing something. We can write in the what? The base of the log, which is 10. If we don't have a base, it's an implied 10. If it was ln, it would be what? Good. Now, can't we convert this to exponential form? This is 10 to the 2nd is equal to 8x. I can rewrite this and divide by 8. So I get x equals 12.5. So that's a tool you can use to solve for missing variables with a log. Now I also just want to mention to you guys, if you want to verify your work at the end of a test or quiz, you can just put it back in the calculator and your answer should come out to be 2. Okay? So just to check your work, that's an option. Alright, letter B. How can I rewrite this to condense it? Ln of, good, x over 4 equals 3. Now I can put the base back in.
Where did ln e come from?
Ln always has a base of e.
Oh,
So we're just putting that base in that we already know it has.
Okay.
And now we can convert it from logarithmic to exponential form, which is going to be e to the equals x over 4. And then lastly, multiply both sides by 4. So this right here would be what we call its exact form, which would be 4 times e to the 3rd. But we can get a decimal approximation for that in our calculators by doing e to the 3rd times 4. So if you do that, you should get 80.3421. Now keep in mind, make sure on the quiz and the test and all that stuff that you go ahead and make sure you look at what it says to round to. Okay, make sure you round correctly. I did see some rounding errors on the quiz, so make sure you got it on the test. I'm going to be definitely more strict about it on the final test, okay? All right. Let's do letter C together. So I got to bring the exponent back in, right? It's addition, so it's multiplication. Then I write back in my base. And I use the arrow method. Oh wait, did I put a 2 there? That's not right. What's the base of this one? Yeah, I don't know why my brain did that. So it's e to the 6th is equal to 2x cubed. Then what do I have to do? Good. And then what can you do to get rid of a 3 exponent? Yeah, you can either cube root or put it to the 1/3 power. It's the same thing, okay? So in my calculator, I like to use 1/3 power. I just find it easier to do. It's the same thing as taking the cube root. Any type of root is the same thing as putting it to the 1 over whatever that root is, power. So I do this as different steps in my calculator. I do e to the 6th, enter, divided by 2, enter, and then the little caret to the 1/3 power. And that should give you this. any questions about that? Alright. And then this one here. Why don't you guys go ahead and try it for a second? I'll put it up in a second. This one's a little bit more challenging, but I think you can all do it. Work?
I'm sorry, guys.
Well, yeah, I was like listening to through the computer. I had it all maxed out. I couldn't hear